Hello there, it's Mr. Guevara, and I'd like to demonstrate a few methods that you could use for addition. If you would like to know how to solve other operations, then I've put a link in the descriptions for you to click on. Now, the first method I'll demonstrate will be using Diennes. Now, as you can see, I've got 1 here. Let this represent a 1. Yep. And 10 of these ones is going to be the equivalent of this. So 10 of these ones is going to be equivalent to 110. Yep, 110 is going to be equivalent to 10 ones. Alright, you can probably see right there how it all adds up. Now, let's take for example 34 plus 23. There we go. We've got 34 plus 23. We're going to use the Diennes to try and expose a few things. Right, so we could use Diennes to partition. That means we're going to break up the 2-digit number into its tens and ones. So we're going to expose its expanded form, so having the tens and the ones. Okay, so if we look down here, we can see that 34, let's partition it first. I'm going to write the number 34 here, and if we partition it, we can see that 34 is going to look like this: 3 tens and 4 ones. 1, 2, 3, 4. Right? So we've exposed it: 3 tens and 4 ones. So if we partition it, 3 tens is going to be 30. 4 ones is going to be 4. So this is the expanded form when you partition a 2-digit number. So 30 plus 4, and you can even draw it out as well. Okay, so you got your 3 tens, see, and 4 ones. So if you don't have your Diennes, then you can always draw them out. Okay, so that's our first number here. Okay, our first addend. So the second addend we can use is the number 23, and we're going to expose 23 like this. So 23 can be written as 2 in the tens and 3 in the ones. 23. So once again, when we partition, we can expose its expanded form, 20 and 3. 20 plus 3. If I use my Diennes, 10, 20, 2 tens, 3 ones. 1, 2, 3. 3 ones. And if I wanted to draw it out, I have my 34 here. I want to do 23, 2 tens, and 3 ones. And then what you can do now is you can total these all together. So if I add all the ones together, 1, 2, 3, 4, 5, 6, 7, you've got 7 ones, and 1, well, 10, 20, 30, 40, 50. So we've got 50 here. But how many tens? 1, 2, 3, 4, 5. We've got 5 tens. So the digit 5 can be put into the tens to make 57. And as you can see here, it looks a bit like a column method to some of you. We can add up all the ones together. 1, 2, 3, 4, 5, 6, 7. I know that 4 plus 3 equals 7, so I might not even need to count the dots individually. My maths is good enough to know that I can put the 7 here. Right? So there's 4 and there's 3. And 10, 20, 30, 40, 50. Right? If you put 50 here, that changes the number. Look here, we've got 57. 5, 7. Not 50, then the 7. So this is where you need to be very careful, because you've got this column here. You only put 1 digit in there. Yeah. And if you put the digit 5 in the tens column, that's going to represent 50. So we've got 57. So this is how you can use the Diennes to work out how to solve numerical problems like this. Now what happens if the numbers that are in the ones place, when you total them together, they become a 2-digit number? how are you going to represent that and put that in your answer? Hey, Mr. Guevara, how are you going to do that? Well, let me show you and tell you what I mean anyway. Here we go. We can take, for example, the number 37. That's going to be our first addend, and then we're going to add 24. That's going to be our second addend. Okay, so the 7 and the 4, that's in the ones place. Let's use our Diennes again, shall we? So 37, 3 10s, and 7 ones. 1, 2, 3, 4, 5, 6, 7. Right, so 37. We've got 3 10s, we've got 7 ones. Let's expose its expanded form again by partitioning it into its 10s and 1s, and we get 30, 3 10s, 30, and the 7 represents 7. So 30 plus 7. If we can draw it out as a pictorial representation, we get our 3 10s, 10, 20, 30, and our 7 ones. 1, 2, 3, 4, 5, 6, 7. Okay, 37, and we're going to add on 24. So we've got a 24. We've got a digit 2 in the 10s and a digit 4 in the 1s. And when we get its expanded form, so we partition it into its 10s and 1s, get 2 10s, which is the number 20, and we get 7 1s, which is the number 7. And we've got this here, 2 10s and 4 1s. Did I write number 7 there? Let's change that, shall we? Right, I spotted my mistake. Sometimes you make a mistake, see where you went wrong, and you can correct it. 24, 2 10s and 1, 2, 3, 4 1s. And as you can see here, I'll do the same, do my pictorial representation. 1, 2 for 2 10s, and 1, 2, 3, 4 for 4 1s. I'm gonna write my answer in here. I've done this to expose another method that you can use, color method, which will be in a different which will be later on. Sorry about that. Right, now as you can see, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We've got 11. So we can't write 11 ones and then 10, 20, 30, 40, 50, which is 1, 2, 3, 4, 5 10s. Because then that gives us the answer 511. Now that is not right. So this is what we have to do. You're going to have to recognize that you've created a 2-digit number here, but look very carefully. I've got my 5 and another 5 here. I've got 10 ones and 1 10 to make, 1 1 to make 10 ones. Yep, 10 ones and 1 1 to make 11 here. And if you look carefully, you can see that yes, look, they match up. I can exchange this 10 1. I can exchange this 10 ones for 1 10. And we get 1 10. So here's my 1 10. I'm going to exchange it. Yes, give me all of that. The 10 ones becomes 1 10. So here we go. I've got 1 10. And I'm going to put this 1 10 underneath here. See that? Now I've got 11. See? And this is the good part. We can now see that all the 10s are together and all the 1s are together. So we've exchanged the 10 ones for 1 10, and we've got a 1 that we can put in the 1s column. And then 10, 20, 30, 40, 50, 60, which is 1, 2, 3, 4, 5, 6 10s. Our answer, our total, is going to be 61. Right? So this is how we can do it with our representation here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to circle this 8, 9, 10. okay, and say that is my 110. Now what I can do is say I'm going to exchange this for 110. So all of this is going to go into this column here. Alright, now I'm going to put it all the way down here. Don't forget that it's there. Alright, this is my 110 down here. All of that 10, I'm going to put it down here. The reason why I'm doing that will be revealed later when we're doing the column method, but I want you to see it like this for now. So now you can see we've got our 110 here. Let's not make it a bit of a muddle there. 110. I meant 11. Here's my 11s here, just like that. And 1, 2, 3, 4, 5, 6 10s. So if we put the digit 6 in the tens column, that represents 60 here. So 37 plus 24 equals 61. That's what you can do when you cross the tens, as it's referred to by some.